for the second question, a 1 millimeter cube tank contain air at 25 degrees C and 500 kilopascal. At 500 kilopascal is connected through a valve. So it's like you have one tank that have the 1 meter cube of volume at 25 degrees C and with 500 kilopascal of pressure. So then this being connected with another tank. So this is what we call a valve. So this tank, we don't know the value, it's not given to you the volume, but given to you that within this container or tank, it has contained 5 kilograms of air at 35 degrees C, and then all of this container is insulated in such a way it's not affected to the surrounding, and then this container is at 200 kilopascal. Okay, so the first question asks the mass of air in this container at the 1 meter cube tank. So what we do is just simply go directly to the ideal gas law. This is what you are very familiar. The constant also given there with the unit as well. Okay, so we are concentrating on the mass, which is we know is related to the mole. So mole is equal to m divided by the molecule mass. So for the molecule mass air given to you, that is 29, which is 29 gram per mole. You should remember that, because you can, if you don't, you can just remind yourself with this equation, but only that this is not in SI unit, is gram per mole. Okay, so we are looking for this n. So n is equivalent, so maybe we can just change it first and then rearrange back all the equation. So right now, if I were to change this right side of the equation, it would give you mRT divided by m. This r still remain to these values. Okay, so we are looking for m. So m, rearrange the equation, give you about PV capital M there, and divide by mRT. No m anymore. Okay, RT. Okay, that's so just simply put all the value there. So remember, so it's a good practice for you to just write down both of the value and also the unit. So if you don't want to have a unit, you can also remove the prefix into a value. So I just prefer myself a unit there, so I know whether it's in the SI unit or not. Okay, so the next one is the volume, given that is 1 meter cube, and m. So that one, just retain it as gram per mole. Okay, and another thing is 8.314 for the ideal gas. The unit is kilopascal. Meter cube per kilomole per Kelvin. So it's quite long, but again, it's a good practice to have it all written down, so that it will help you along to avoid unnecessary mistake. So temperature given to you is Celsius. So because you're aware of that unit, so you know that this one you need to change into Kelvin. So 273.15 plus 35. Okay, so since that the unit is a bit all the way there and there, so you might well see that how things are cancel out each other. So if you look at here, this is per mole, and then this was also per mole, so should be cancelled. The reason that we can't cancel it because of this k. Okay, so we can change that k if we added this k on top of there. And then if we, since that we already add this k, we also need add that k on top in front of the g, because I multiply 1000 at the denominator, and then I multiply another 1000 at the on top of it, so it should give you 1. It doesn't change the value. Okay, so with that I can cancel both of these per kilomole, and then this kilopascal can change, so I don't need to include the kilo within the calculation, because I can just cancel both of that out. Okay, if you want to remove the prefix, you have to remove all of the prefix in such a way that it still could cancel each other. Okay, so this I forgot that this one is in Kelvin, so all of them in Kelvin. So again, Kelvin will cancel. So Kelvin cancel, kilomole cancel, meter cube cancel, kilopascal cancel. Then what remains, your value will be in kilogram. So if you just remove all the prefix, then this one will be just gram per mole, then your answer will be in grams. So that is how you check what unit your answer are. Okay, so in this case the answer for the first question is 5.85 kilogram. Okay, for the second one, is the same as A, but the difference is we are looking for the second tank, and the second tank, the difference with the second tank, it does not give you the volume. Instead it gave you, the question give you the mass. Okay, so we just have to use this equation, PV MRT, the one you already change with the mass. So right now we want to determine the volume, so just make the volume to be the main component, so MRT divided by PM. So anything here is not related to the question 1, because question A here only discuss about for the tank 1, for this is for tank 2. Okay, so M is given in the question is 5 kilogram. Remember, so it's a good practice to write down all the unit given. If the unit is not given to you, especially for the constant, you can ask. So this one again given in kilopascal per meter cube, kilomole per kilomole per Kelvin. So we have temperature on top here. Temperature is again it's in Kelvin. So I think I think this one shouldn't be 35, should be 25, which is here. Okay, but you still get that value, don't worry. So here it should be 27.15 plus, so this time is 35. So all of these are in Kelvin. So all these are then divide into 2 with 2 kilopascal, and here is the same 29 gram per mole. So we can just practice the same thing, because we want to cancel the kilomole with the mole here, because both of them are per mole. Okay, maybe I should write down in the similar methods. So this one is per mole, so we can actually cancel both this, but the one that holding us back is the K, the kilo. So if we want to add this kilo, we have to add on top of it as well, so kilogram per kilomole. So if I want to remove this, I also could do that in such a way. I remove this K, then I remove this K, because this one is on top of this mole. Okay, but then you have a problem to cancel this unit kilopascal. But if you change this kilopascal, this with kilo into times 10 power of 3, then still could do it. Okay, so again, so what we're going to expect the value, because this kilogram will cancel with kilogram, kilopascal, cancel kilopascal, kilomole, cancel kilomole, Kelvin with Kelvin, then we will get in the meter cube. So whatever the value you go obtain, you will get in terms of meter cube. So in this case, your value you will obtain from this calculation to only taking out all the value. You don't need to consider kilo anymore because of or any of the prefix, because we already make it similar on top. We cancel out each other, then give you these values. Okay, so we need to shrink things up a bit. Don't have a space here. Okay, that should do it. Okay, for the third question. Okay, so the third question is we have to look back onto this figure. Okay, only then at question C, the valve here is being opened. We remove the valve when we allow the gas to flow. Okay, we allow the gas to flow, so it doesn't matter whether it's possible or not. In this case, you just try to look what is the possibility. So what happens when we allow it to flow? The final state given in the question is that it reached a temperature of 20 degrees C. Okay, so the question asks is what is the pressure, the new pressure. So to answer that, if you look back to the equation what we've been constantly use, PV equal to M RT over M. So given here T is being given there, so we want to find P. So we don't have, it doesn't give you V and M. This R and M is the same as the previous question, so we need to determine V and M for this case, not just this or the other one. We need the system that combine both of them. Okay, so the combined system have the volume of VA plus VB. So A is referring to the question A, VB is referring to the volume question B. So what is the volume given from the question A is 1 meter cube, and for the second volume you just obtained here is 2.209 meter cube. Thus give you the total volume of that is 3.209 meter cube. So you get the new volume. And what about the mass? So mass you obtain initially is for the first question is 5.85 kilogram, and then the other tank also have its initial mass which is 5 kilogram. Then we can say the total mass that reside within the both of the tank is now 10.85 kilogram. So we got the value of V and M, so we can determine the new pressure by inputting all these values. So what is the pressure? Pressure will be equal to MRT over MV. So the total mass here is 10.85. Again, a good practice to write down all of the units. Then is R 8.314. This one will be a bit long, so I try to write it down in a shorter form, kilopascal meter cube over kilomole Kelvin. Okay, because we are short in space there. And the temperature is 273.15 times 20, which is Kelvin. And molecular mass is again given as gram per mole, and the volume we obtain here is 3.209 meter cube. Okay, so if you look again, meter cube with the meter cube, we could cancel. Again, the problem with the kilomole, we have to add k there and k there. Okay, so we are able to cancel the kilomole. We also able to cancel with the kilograms, and then we also able to cancel with the Kelvin here, and thus give us the value will be remaining is as in kilopascal. So that's you by just calculating the numbers here does not change. You don't need to change any of the prefix. You will obtain the value is 284.2, approximate that value. Then the unit will be in kilopascal, because here we have that kilopascal. So that is the second question.